So this is question number 11, and it wants us to determine the test interval by using a number line or sign chart, and then we're going to solve the inequality. So we first need to get all our terms to one side. I'm going to do that for part A by subtracting 2 from each side. So that gives me x plus 3 over x minus 1 minus 2 is less than or equal to 0. But what I need to do now is find a common denominator. And that's going to be my x minus 1. So here, when I distribute my 2, I get x plus 3 minus 2x plus 2 all over x minus 1. That has to be less than or equal to 0. And so I can combine. I get x minus 2x gives me negative x. 3 plus 2 gives me plus 5 over x minus 1. And so for our test interval, remember that not only are we putting down the numbers where our numerator would equal 0, but also our denominator. So here, if I set the numerator equal to 0, I've got negative x plus 5 has to be equal to 0. So I subtract 5, and I get negative x is equal to negative 5, and I divide through by a negative, so I get 5. And then on the bottom, when I set the denominator equal to 0, I get x minus 1 is equal to 0, so x is equal to 1. So what I'm going to do now is pick values in between those numbers to see which intervals I'm picking and which intervals I'm excluding. So if I test the value 0, I get 0 plus 5 is 5 over 0 minus 1, which is negative 1. So 5 over negative 1 is negative 5. Is that less than or equal to 0? Well, yes, it is less than 0. So I do want the interval that is less than 1. Now if I pick a number in between 1 and 5, so say I test the value of 2, I plug it in and I get negative 2 plus 5, well that gives me 3 over 2 minus 1, which is 1. So it gives me 3 over 1, and is that less than or equal to 0? Well, no, it's not, because 3 is greater than 0, so we don't want this interval here. And then if I test the value of 6, negative 6 plus 5 is a negative 1 over negative 6 minus, 6 minus 1, which is 5. So I get negative 1 over 5, and that is less than or equal to 0. So I do want the values here. So when I go to write the answer to this, I know that my answer is going to be from negative infinity up to 1. But do I include 1? Well, that's a good question, because I want it to be less than or equal to 0. However, my 1 came from my denominator, so that's where it's undefined. So I can't have 1. So it's going to be parentheses union with 5 to positive infinity. And I do include 5 because when I plug in 5, that gives me, that's equal to 0. And so since I want it to be less than or equal to, that's okay. So my answer is from negative infinity to 1, union bracket 5 to positive infinity. So then we're going to repeat those same steps for part B. In part B, we're going to subtract x, so we get 3x minus 8 all over 5 minus x, and then we're going to find a common denominator, so multiply that by 5 minus x on the top and the bottom. That's going to be greater than 0. So when I distribute, I get 3x minus 8 minus 5x plus x squared all over 5 minus x. So I simplify on the top and I get x squared plus 3x minus 5x, so that's minus 2x minus 8 all over 5 minus x. Or, yeah, 5 minus x. There we go. So I know that my numerator will give me a value of 5. Or sorry, my denominator will give me a value of 5. My numerator, when I want to set that equal to 0, I'm going to solve and I factor it out. And my factors of 8 are 2 and 4, and that's good because that'll give me a negative 2. So that would be, when I factor it, let me rewrite it over here. This factors to be x plus 2, x minus 4. And so then my values of x are negative 2 and positive 4. Alright, so then once I have my number line, I can pick values in between. So I'm going to rewrite this numerator as my factored version. So that gives me x plus 2, x minus 4, all over 5 minus x. has to be greater than 0. And now that I have that, I test values that fall in between that. And so I test 0, because I think 0 is always the easiest to plug in. And I get 0 plus, so that's a positive. 0 minus 4 is a negative, so positive times negative is a negative. Over 5 minus 0 is a positive, so negative over positive is a negative. Is that greater than 0? Well, no, it's not, so we're not including that section. I plug in a negative 3. I get a negative times a negative, which is a positive over a positive, so that is good. If I plug in between 4 and 5, so 4 is 8 halves, 5 is 10 halves, so in between that is 9 halves. If I plug in 9 halves, I get a positive times a positive, which is a positive, over a positive, so that is A-okay, that's positive, so we want that section. And then if I plug in 6, I get a positive times a positive over a negative, so that's a negative, I don't want that. So therefore, my interval for this problem is going to, my answer in interval notation will be from negative infinity to negative 2. And do we include 2? Well, no, we don't, because this doesn't want equals 2. This just wants greater than x. So we're gonna have parentheses for all values. Union with the interval from 4 to 5, and that is your final answer for that. So that's A and B. Now we're gonna do C and D. In C, we've got x minus 3 over x plus 3 is greater than, or sorry, is less than or equal to x plus 3 over x minus 3. So again, we're going to bring everything to one side and find a common denominator. The common denominator is going to be x plus 3, x minus 3. So we've got x minus 3 over x plus 3 minus x plus 3 over x minus 3. Has to be less than or equal to 0. We're going to find a common denominator, so we need to multiply this one by x minus 3 over x minus 3, and this one by x plus 3 over x plus 3. So I get x minus 3 quantity squared minus x plus 3 quantity squared all over x plus 3 x minus 3, and all that has to be less than or equal to 0. So I'm going to square out my top terms, and this will give me x squared minus 3x, so minus 6x plus 9 minus, and then this gives me x squared plus 6x, but it's times a negative, so it's minus 6x plus 9 times a negative is a negative 9 all over x plus 3 x minus 3. So with that, we can go ahead and cancel out some things. I can cancel out my x squareds, and I can cancel out this negative 9. I'm going to have to erase some more of the board. Okay, and so I'm left with negative 6x minus 6x over x plus 3 x minus 3. This has to be less than or equal to 0. So that gives me negative 12x over x plus 3, x minus 3 has to be less than or equal to 0. So we're going to set the top and bottoms equal to 0 and put those values on our number line. The top, just x equals 0, and we can include that because it'll equal at 0, this will equal 0, and we want less than or equal to, and then we get a negative 3 and a positive 3. So you can just go ahead and test a number. If I test 1, I get a negative over 1 plus 3 is a positive times 1 minus 3 is a negative. So negative over negative is actually a positive, but we don't want positives. We're looking for negatives, so we don't want this section. And then if I test negative 1, I get negative 1 times negative 12 is positive 12. So it's positive over negative 1 negative 1 plus 3 is positive times negative 1 minus 3 is negative. So it's a positive over a negative, which is a negative, and that is what we want because that is less than 0. So that is good. If I test negative 4, I get a positive on top. I get a positive on top over negative 4 times plus 3 is a negative, negative 4 minus 3 is a negative, negative times negative is positive. So positive over positive is positive, but we're looking for negative numbers, so we don't want that. And then when I test positive 4, I get a negative over a positive, which is a negative, so we do want that. So then our interval is from negative 3 to 0, union, and that negative 3 actually has a parentheses because it's what makes our function undefined, not defined. So it's parentheses negative 3 to 0, union with 3 to positive infinity. So that is part C, and then we have one more for this. I know it's a really long problem. Got part D. Part D gives us this insane looking function. It's negative 1 minus x quantity squared times x plus 2 quantity cubed plus 6 minus x quantity squared all over 1 minus x quantity to the 5th, x plus 2 quantity squared, and x plus 5 to the 1. So, what we're going to do first is simplify. So I know I can get that out of the top, and this is left with 3. And then get this out of the bottom, and this is left with 1. So our real function looks like x plus 2, 6 minus x quantity squared, all over 1 minus x cubed times x plus 5. All this has to be less than or equal to 0. So on a number line, all of our values are going to be, we have a 6 over here, a negative 5, negative 2, and a 1. So that's all of our test values. And so now we need to look and see. So actually what we can do is we can look at multiplicities for this. Since they want them to be less than or equal to 0, we're looking for the negative values. So what I'm going to do is I'm going to test 0 as my test number, and then what we're going to be able to use is multiplicity on either side to quickly fill in our sign chart. So at 0, we get a positive times a positive over a positive times a positive. So this is obviously positive. And so what we're going to do, when x equals negative 1, we've got an odd multiplicity, which means it's changing there. At x equals negative 2, we've also got an odd multiplicity, which means it's changing there. At negative 5, odd multiplicity, so it is also changing there. And then from 6, we've got an even multiplicity, so that means it stays the same. So, since we are looking for less than or equal to 0, we want from negative 5, and negative 5 is in our denominator, so we're going to use parentheses, to negative 2, and negative 2, however, we still have to use parentheses because even though we canceled it out to simplify, it was still originally in our denominator, so we can't use a negative 2. Union with 1, which is in our denominator, so we also don't use 1, 2, positive infinity. And the reason we don't specify 6 is because at 6 we're either at negative or equal to 0. So from 1 on, it's fulfilling this. So that's why we don't have to specifically step out and state 6 as well. So that is your answer to question number 11. It's a long one, but that's it.